Look, we all know that autophagy is a great strategy to slow down the aging process because autophagy is the body's natural way to recycle cellular components and revitalize the cells. And fasting is a great way to ignite autophagy. But what if you hate to fast? Well, today we're going to talk about a natural compound that can induce autophagy without fasting, and that's spermidine. Before we get started, I'd like to take a moment to remind you guys that for the next few weeks, I'll be posting videos less often than I was because I'm in the process of putting together an online course, and that's taken up a lot of my time. I announced this in the last video, and I was surprised by how many comments I got that were in support of the online course. If you'd like to be put on a mailing list to be notified about updates in the course or how to enroll in the course, click on the card that's right up here, and that'll take you to a page where you can send me your contact information, and I'll make sure that you're on the list. In today's video, we're going to be taking an in-depth look at spermidine, a compound that might possibly extend your lifespan in a different way from other interventions. We'll take a good look at what spermidine is, how it works, the impact that it can have on the aging process, and how you can boost your spermidine levels through your diet or through supplementation. But before we get into the unique ways that spermidine interacts with your body, we need to take a look at what spermidine is. At the molecular level, spermidine is a polyamine, which is simply a compound with more than 2 amino groups. And it's endogenous, meaning that we produce spermidine in our own bodies. In fact, it was first discovered in human semen, which is how it got its name. Now, this was way back in 1678. And it was discovered by one of the pioneers of microscopy, Anton van Leeuwenhoek. But since then, spermidine has been found in all the cells in the body. It can be created in tissue or by bacteria in the gut, and it seems to be a universal prerequisite for growth, along with some other polyamines. Okay, so how does spermidine work? What does it actually do? Well, simply put, spermidine induces autophagy. Autophagy is Latin for self-eating, and it's a process that goes on inside of our cells. When nutrients are low, the cells can generate additional energy by recycling old or worn out, malfunctioning cellular components. But in addition to producing energy, this process renews the cell and revitalizes it, and it makes it more healthy. So autophagy is an important process within the body. Under normal conditions, autophagy is ignited in the body by fasting, and you need to fast for at least 24 hours to induce autophagy. And that's just to set it off, to get it started. You want autophagy to continue for a while, which means that you need to continue your fast for a lot longer than 24 hours. But let's face it, fasting is unpleasant for most people, and it requires a lot of discipline. That's where spermidine comes in. Spermidine can induce autophagy without having fasted for 24 hours or having fasted at all. And the way that it does this is pretty interesting. Spermidine inhibits acetyltransferases. Now, while this reduces the acetylation level in cells, it also inhibits mTORC1, or the mechanistic target of rapamycin complex 1, something that the longevity drug rapamycin also does. Now, this activates the AMPK pathway and starts up autophagy. So spermidine ignites autophagy by inhibiting mTORC1 and activating the AMPK pathway. All right, we know what spermidine is, how it's created, and what it does. What kind of impact does all this have on the aging process, on longevity? Well, the answer to that is kind of profound. By inducing autophagy, spermidine impacts a lot of different aging pathways. If you've been following this channel for a while, then you know that I'm a huge fan of fasting because fasting ignites autophagy. And autophagy has been shown to be hugely beneficial for health and for longevity. But beyond that, spermidine has been shown to have some very specific effects. First, as I mentioned earlier, it's a prerequisite for growth and the proliferation of cells. But it's also been shown to have a beneficial effect on both inflammation and on apoptosis, the programmed death of cells. Spermidine also works by influencing lipid metabolism. Lipid metabolism helps to regulate your lifespan, and if this process becomes dysfunctional, it can have dire consequences for your health, your lifespan, and ultimately how you age. And a big part of this is adipogenesis, the creation of fat cells from stem cells. Spermidine is apparently indispensable for adipogenesis, and it helps to modify your lipid profiles. Next is the impact that spermidine has on cognition and memory. There was a mouse study carried out at the University of Graz in Austria by Sabrina Schroeder and a team of researchers. This study examined how autophagy led to improvements in mitochondrial activity in the brain, and this autophagy was ignited by spermidine. Autophagy improved mitochondrial function in the brain, which resulted in increased ATP production, or more energy for the brain to use. And this can slow down or even reverse the cognitive decline that comes with aging. This study also found that dietary spermidine has the ability to cross the blood-brain barrier, which could also improve cognitive performance and partial learning memory. Now, scientists have not exactly been able to fully comprehend what the relationship is between autophagy and learning memory. But from the evidence, we know that autophagy triggers the learning memory mechanism and also helps to improve cognitive performance, especially in aging animals. The researchers carried out tests on the hippocampi of mice. The hippocampus is the part of the brain that plays the central role in memory formation. They found that taking in spermidine helped to enhance respiratory capacity for the mitochondria, which not only helped them to better understand how spermidine works, but also demonstrated that taking spermidine improves cognition and memory in mice. But mice have very similar aging pathways when compared to humans, and the results look very promising for us two-legged types. But does taking spermidine actually extend lifespans? In a mouse study that was published in January of this year, researchers sought to find out how spermidine would affect the organs usually affected the most by aging. So for 6 months, they administered aged mice with spermidine through their drinking water. At the end of the trial, they found that the mice that were treated with spermidine showed appreciable anti-aging effects, unlike other mice of the same age who weren't treated with spermidine. Thanks to the spermidine treatment, the mice used in the experiment developed less kidney and liver damage. Also, the bald spots typically found on aging mice were decreased in mice treated with spermidine. What impressed the researchers the most, though, was how spermidine functioned to help protect the heart. Spermidine helped to reduce the shortening of telomeres in cardiac tissues. Telomeres are the caps on the ends of chromosomes that prevent the strands of DNA from being eroded. And in the mice treated with spermidine, the telomeres were almost the same length as those in younger mice. So all of the aforementioned research begs the question, does taking spermidine actually improve lifespans in humans? Well, apparently it does. A study done in 2018 concluded that 2 prospective population-based studies report for the first time that nutritional spermidine uptake is also linked to reduced overall cardiovascular and cancer-related mortality in humans. Now, these studies were based on food questionnaires where they calculated the amount of dietary spermidine each individual consumed in their diets. High spermidine uptake constituted an independent prognostic parameter for reduced mortality, meaning that this variable predicted a reduced incidence of death even after correction for possible confounding factors such as age, body mass index, consumption of alcohol or aspirin, diabetes, metabolic syndrome, physical activity, sex, socioeconomic status, and even dietary quality, supporting the idea that spermidine might indeed be causally involved in the reduction of overall morbidity and mortality. Now, one of the great things about this study was that this was spermidine that was normally consumed in their diets, not from supplemental spermidine. Now, there's a point that I'd like to make. If spermidine can activate the AMPK pathway and shut down mTORC1, all on the way to igniting autophagy, what effect does taking rapamycin have on taking spermidine? I looked through the research and I can't find a thing about the effects of taking spermidine and rapamycin. If they both shut down mTORC1, is spermidine possibly a substitute for rapamycin? What happens if you take them both? Do they magnify the effects of each other? And what about fasting while taking spermidine, or spermidine and rapamycin? It's obvious that a lot more research needs to be done here. If you guys have any info on this, let me know in the comments. Okay, so where does all this leave us? Unfortunately, spermidine levels, like just about everything else, go into decline as we grow older. So all the endogenous means of creating spermidine in the tissues of our bodies or in our gut won't do us any good here, which means that we need to turn to exogenous sources. Now, the good thing about spermidine is that you can easily get it from the food that you eat, mostly from plant and fungi-based foods. So, for example, you'll get a good dose of spermidine from vegetable sprouts, mushrooms, peas, cauliflower, and broccoli. Now, these veggies all have significant levels of spermidine, and it's great to know that spermidine seems to be stable in the presence of heat. This means that cooking your vegetables won't destroy the spermidine in them. Now, unfortunately, animal-based foods are not a great source for spermidine. For example, in 1 gram of mushrooms, there are about 160 micrograms of spermidine. In comparison, 1 gram of meat only gives you about 20 micrograms of spermidine. So, if you really want to get the benefits of spermidine, you might want to eat more plant and fungi-based foods. Next, let's talk about bioavailability. Spermidine is absorbed in the gut very easily, even though it doesn't get metabolized completely. Your body metabolizes about 40 to 80% of the dietary spermidine that you consume. Okay, but what about safety? Good news is spermidine is very safe to take, which makes sense when you think about it. You're supplementing with something that the body actually makes on its own. There was a randomized, placebo-controlled trial carried out for 3 months. During that trial, 1.2 milligrams of spermidine were administered to one group, while the other group was administered a placebo. At the end of that trial, it was found that spermidine is a completely safe supplement to take. On a side note, one thing that was also noticed during the placebo-controlled trial is that spermidine might help with hair regrowth. Those in the group treated with spermidine experienced an increase in hair growth from the hair follicles compared to those placed on the placebo. Now, even though you can get all the spermidine that you need through your diet, I know that some of you will want to supplement your dietary spermidine. There's a company out of Austria that offers pure, natural spermidine in supplemental form. They extract it from non-GMO wheat germ, and according to Dave Asprey, it's the first spermidine supplement that he's found that meets his criteria for clean ingredients. The company is called Spermidine Life, and I've included both a link to their product as well as a discount code in the description below. Okay, that wraps up another video. I hope you guys enjoyed it. In the meantime, have some shrooms and boost your spermidine levels. And you might want to check out this playlist on balancing the AMPK and mTOR pathways. I'm out of here. Catch you guys next time.